I'll be taking you through C programming. Um, yeah. I'll be taking you through C. Hello everyone, yes, I'm back. I'll be taking you through something today, and that is C programming. This is exactly what I'm going to take you through today, C programming. Yeah. So we're going to do something in C programming today, which is finding the quadratic equation. Yeah. So here we're going to deal with math equations. So what we do in our program, we must include the value for math. Yeah, which really show that it's a math equation. So and then that using the namespace that is minor. So it can either be put or even not. Yeah, and then we shall find the what? We shall find the our coefficients. Like we find those values, like we say the characters a, b, and then c. Remember our quadratic equation is given by minus b plus minus the root of b squared minus 4ac divided by 2a. And so the values, we shall find the discriminants. So our discriminants will be b squared minus 4ac, which is that value in the root values. So after finding that, we shall get if the discriminant is what? It's less than 0. What happens if the discriminant is greater than 0? I mean, when it's greater than 0, we shall say the negative b plus the square root of the discriminant divided by 2a. We shall first take it when it's a positive, and then we try it when it's also what? A negative. So we find that the roots are real and distinct when you try to put into that. And then when we continue, um, when you continue putting into that, you keep finding that these roots are real and distinct in every step you put that is less than 0, that is greater than that, when the discriminant is what? Is greater than 0. So we shall also try it when the discriminant is equals to 0. So when the discriminant is equals to 0, the root of b negative b divided by 2a, we shall find still that the roots are real and what? And are equal. So when you keep trying that, you find that these roots are still real and equal in every part you try to put on those what? We try to feed in those coefficients. Yeah. And then we shall find elsewhere when the roots are what? The real parts. So when you find when it's imaginary, it's equals to the square root of the discriminant divided by 2. When you try that, when the imaginary roots, we shall find that the what? The the roots are complex and conjugates of each other. So when you find the first root might be what? A conjugate, the other might be a complex number. Yeah. So when you keep trying on that, you find that these values keep on varying depending on the input you put, the coefficients of the values you're always intending to do. And then finally, when in running this program, you must include the value int main this, so that you're able to to run and complete your errors. So we shall have this. Remember our coefficients, the characters. So we enter when after now we are running our program. Like after this, we shall compile and then we run the program. You see whether it's what it really give us really the real and a distinct part of the what of the root. So we shall try to calculate this. We shall enter the coefficients. After entering those coefficients, so then we try that if a is equals to 0, we calculate the roots of a, b, and c. But then it must return what? 0. So let's try to compile this and see what it really gives us. So when we say compile, when you compile, what happens? We find that when you compile, we get a 0 error, and then 0 warning output file that it brings all that, yeah, and then output size, that's all it brings, yeah. So that's what really brings 0 errors and all that, yeah. So that is what it really brings. So what do? We run the program. So let's run it. When you run the program, let's try entering some coefficients. So let's say our a is 1, b is maybe, let's say b3, and then c, let's say c is -9. Then what do we get? Enter. We find that these roots are real and distinct, meaning the first root is a real root, and then the second root is a distinct root. That is what it simply means. So let's try to feed in other roots also. We see. So what about when you say a is 1? We say B, maybe let's say B is 2, and then C is what? Is 8. What do we get? We still get that the roots are complex and conjugates of each other. We find that the first root is a complex number, and then the second root is a conjugate of the very complex number, the very first root here. So this is what we finally get. Yeah, so this is a continual thing. You can continue putting on, feeding in coefficients, feeding in the values. You can still find this very stuff. So thank you so much. Thanks so much for watching this video. Let me wish you all the best of your time. Don't forget to like, subscribe, and follow for more. I love you all. Enjoy your time together.